In the previous video, we did a setup of a development environment, so we could like start writing Algol 68 programs. And so basically, we installed GCC, we installed the compiler, we installed the Autotools with support for Algol 68, and the Emacs mode for actually editing programs. So today, we will be creating like the bare bones of a new Algol 68 project. This video could also be useful maybe as a very quick and small tutorial on how to set up a new project using the Autotools. So let's get at it. So the first thing that we need to do when we start a project is to decide how the name of the project, which some people say is the most difficult part. So in our case, we are gonna call our new project GRAMP. GRAMP will be meaning at some point grammar manipulation program, which is one of the programs that we will be doing in those areas. Okay, so we start with an empty directory. Then the first thing is to create a Git repository. It is handy, it's useful so you can start tracking changes, start right at the beginning. This Git repository it only exists in the local machine at the moment. It's not hosted anywhere, which is perfectly fine. So git init, this creates a new a new Git repository here. So the first thing that I always add to a new Git repository is a git ignore file. And the first entry I always put in the git ignore file is are files ending with tilde, because those are backup files used by Emacs, and as you can see, I use Emacs a lot, and also other programs. So we register the new file in Git. This is the Emacs VC mode. That was equivalent to do this. All right, then we want to commit the git ignore file so it starts actually being effective immediately. Now, at these early stages of any project that I start, I never bother using like meaningful commit messages, so I just use foo. I call this the foo stage. If you look at my projects and you do a git log, if you go to the right to the beginning, you will see like half a year of foos there, and that corresponds to the part where I was working in the project before making it public. So foo stage, every change is a foo. Okay, so now we have a git ignore file. The next step is to create a readme file. So let's make like a small one, like ramp, the grammar manipulation program, and then here well, we are leaving it empty because there is not much we can say here at the moment. So we register the file in the Git repository. Right, so we have a readme file. Then what else we need? Okay, then what we're gonna do now is that we are gonna structure the different directories of the project. We are gonna use a very, very common and typical hierarchy, which is the source files, the source code of the project, we are gonna put in src. And we are also gonna have a test suite that we are gonna put in a directory called test suite. Those are customary names, no surprise here. Okay, so for this project, we are gonna use the GNU Autotools as the build system. The Autotools are the best build system ever around. And okay, I'm not gonna get into there. So Autotools basically means that we will be using autoconf and automake. So let's start with the autoconf. So the way we configure autoconf is by creating here a configure.ac file at the top level. And okay, off screen, obviously I have some previously written configure.ac file of mine. Why? Because at the end of the day, you will see that you always do that. I mean, you write your configure.ac and then you continue reusing it again and again and again and again, but which is perfectly fine. So the first thing, configure script, configure.ac files, they usually have three different parts. The first part, which you can call the prologue, is where you introduce yourself, introduce the project. It's a very declarative part. So the first step in the prologue is to say AC init, which basically means that, okay, what's the name of the project? Okay, the project is called ramp, and what is the version, the current version of the project? We are gonna use 1.0, and the moment this is more than enough. AC init, it accepts more arguments, which are optional, that you may want to start using at some point, but for the moment this is more than enough. Note something here. We are quoting the arguments we pass to the macros, those are M4 macros, with square brackets. In principle, this will have worked because there is no special characters here, but as a rule of thumb, it's always good and a very good practice to always quote the arguments that you pass to autoconf macros, because then you are always playing safe. It can go wrong. Okay, so this is ramp, this is the version 1.0. The next part in the prologue of the file is basically we are gonna use this config auxdir macro, which this is basically telling the Autotools that the directory where to pull auxiliary files and also from where to read some auxiliary files is called build aux. This name is customary as well, is the name that everyone uses, and it may also be the default, but I'm not sure about that, and honestly I don't give a shit. It's better to specify it explicitly. I always do, and it works. Then the next macro that we are going to use is am init automake. So as you know, the Autotools, the two main parts are the autoconf and automake. As a user, you can consider both, as part of the same thing. It is possible, certainly possible, to use autoconf and not use automake, and vice versa. Not many, but some projects do that. Some projects use autoconf to check for system features, so to provide a configure script, but then they write the makefile.in files by hand. Some projects don't. Most projects don't. Most projects use both autoconf and automake at the same time, and certainly that is going to be our case here. So we have to initialize automake. And we are done with the declarative part of the configure.txt file, right? Actually, we can do it like this. Okay. The second part of the file is where we actually do checks, because that's the purpose, that's the point of a configure script, to check stuff in the system. So you can configure the sources so they will build properly in the system where you are building. So in our case, we are gonna start with only one check, which is our project is written in Algol 68, so we obviously need to check for an Algol 68 compiler. So for that, prog, not proc, A68. So this is a macro that is provided by autoconf. That's, this IAC prefix. And it basically checks for some suitable Algol 68 compiler in the system. So this macro is provided by the Algol 68 support that we, as the GNU Algol 68 project, added into autoconf recently. And this is the support that the autoconf that we installed in the previous video. So this macro is available and we can use it. And for the moment, this is the only check that we are gonna do in here. We will see that as we advance in the project, we will be adding in more stuff here, but this is the bare bones, minimally functional version. So this is all. Then now we go to the last part of the script, of the configure.txt file, which is like the epilogue. We could call it epilogue. So we have done some checks, and now what a configure script actually does when it gets executed. When you do configure blah, it does some checks. Checking for this, checking for that, checking for a C compiler, checking for an Algol 68 compiler, checking if your compiler supports this option, checking if this library exists and is available, checking if the header file, whatever defines this macro or this other macro, checking for some particular tool, like for example, if you are a kid of today, one of those kids of today that like to use Markdown and all that stuff, if you write the documentation of your project in Markdown, then you are going to need a Markdown processing tool. Now, if you need that at build time in your project, then you need to check at configure time for a suitable Markdown processing tool. So then you would use an AC check proc macro here for the Markdown processing tool. So that's the checking. Yeah, but when the configure script is done checking for whatever it needs, then it has to do something with that information. What is that? So all the configure script knows to do is to get whatever foobar blah.in file, which very often is a makefile.in file, but it could be anything.in. It performs substitutions based on what it found during the checking phase, and then it writes out the corresponding foobar file. So most often it's makefile file. Configure generates makefiles. From what? From makefile.in files. Then it reads a makefile.in. It performs some substitutions inside the makefile.in, which is some sort like of a template, this makefile.in file, and then it writes out a makefile, which is the one that you actually use when you do make in your project. And the idea is that the makefile.in is like generic in the sense that it has marks here and there that the configure script substitutes into some concrete makefile that should be able to build your sources in the particular system where you are building. And all this without needing to have autoconf on the user side, which is the magic of this, but okay. All right, so how does the configure script know which files to actually rewrite and process? Well, we specify this list of files with a macro called acconfig files. Yeah. And this macro gets only one argument, which is a list of files to rewrite. So here you specify the output file. So as we will see, we are going to need a top level makefile, a makefile inside SRC, and a makefile inside testsuite. So the output files are going to be makefile, SRC makefile, and testsuite makefile. So in this macro, you are declaring those like to be like the config files, which it's a very bad name for this macro that they used, but okay. So those are the list of output files that will result from running the configure script. So from this, the configure script will be looking for a top level makefile.in, src makefile.in, and testsuite makefile.in. And then the last macro that we are going to use is do it, which is AC output, which is do it. Read a makefile.in and output makefile. Read an src makefile.in and output src makefile.in, and read a testsuite makefile.in and output a testsuite makefile. And this is all, people. This is all. This is the minimum working and functional configure script for our new project. As you can see, it's very declarative. It's very simple. You know this, oh, the auto tools are so difficult to use. Bullshit. Okay? Bullshit. They are not. You can see here. Okay. So we got a configure.ac file. I don't know if we okay, then we register this in the Git repository. All right, now we need the make files. So let's start with the top level one, which is the easiest one. The top level makefile.am .am is the output, the input for automake, right? So we are gonna use here a recursive strategy. I know recursive may consider harmful, blah 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 blah. I don't care. I like recursive makefiles, and nobody has been able to show me a compelling argument, practical compelling argument on why this is harmful. People love to say that stuff that they don't like is harmful, including me. I have a big mouth. Anyway, so the top level makefile is gonna recurse into the not top level makefiles, and in automake you do that by saying subdirs, and then which one are the sub makefiles? Well, in src the directories, and in testsuite. So this basically means that when we do make, the generated makefile is going to recurse first in src and then in testsuite, right? Which is very logical order. Okay, now let's get into the let's add this to the Git repository. In src we are going to need a makefile as well, right? But this time it's going to have to do something more than just recursing into some other directories. Right, so this is our source directory. This is our source directory, and this directory is going to contain the source files for our project. Now, what is our project? What is in what it consists? In the case of GRAMP, it is a program. So at the end of the day, when you do make in our project, you will be building an executable, perhaps some shared objects as well that are used by this executable, but the product is a program. So, and the source code for this program is going to be in this directory, in this src directory. So automake works with it's very declarative. What you do in a makefile.am for automake is that you declare something called primaries. So one of the kind of primaries is a program. So in each makefile.am, you define a set of primaries that will be built when you do make. So in this case, we want a program called GRAMP. Now, the way you define primaries is something like this: bin underscore programs equals GRAMP. What is this doing? This is declaring a primary called GRAMP, which is a program, and it will be installed in bin, under bin. Well, first it will be installed when you do make install, and it will be installed where? In bin, right? Okay. This bin, it doesn't mean specifically user bin or just root bin or opt whatever bin, or name it. No. We abstract ourselves from where the program is going to be installed, because the user can specify it when configuring the source, so we don't care. This is whatever directory that will be appropriate to put the binaries in, right, in the system. This is nice because automake allows you to abstract yourself from details like that. Anyway, so this is, in fact, this is a list. So if we will want to build more than one program in this directory, we will do full bar. This will be defining 3 different primaries, but we only have one program, at least for now. Right. So when you specify, okay, I have one primary, which is GRAMP, which is a program which is installed and should be installed under bin, then well, you have to specify which are the sources of this program, of this primary. So for that, to specify attributes for primaries in automake, you do something like GRAMP, which is the name of the primary, sources, in this case sources, and then what is going to be the source file for GRAMP, the main source file. So it's going to be gramp.a68. Okay, now observe, we are specifying here the extension of the source file. Automake, this version of automake that we are using, knows about Algol 68, which is automake 1.18 or later versions. So it knows that in order to compile this particular program, this particular source file into an object file, it needs to invoke the Algol 68 compiler, which has been found by the configure script, right? And also, it knows that when it compiles to get gramp.o from gramp.a68, it has to use whatever options are in the environment in the A68 flags environment variable, right? Do you recall for sure C flags for C, CXS flags for C++, and so on? Well, there is an A68 flags as well. Okay, good. Oops. Okay. In fact, in Automake, you can specify per primary additional options. So let's say that we want to add Algol 68 flags which are specific to GRAMP, to this program GRAMP. We could do it this way, like for example, -f A68 check-in, which this is a GNU GA68 GCC Algol specific command line option that tells the compiler to generate code at runtime to check for nil accesses. Or we could, alternatively, we could define it for all the Algol 68 programs primaries defined in this file, and we will do it like this. Which is, okay. So in this case, since we only have one primary, we will do it like this because it's nice. You define the primary, you define the sources of the primary, and you define the flags, the compilation flags to use for this primary when building this primary. And this is all. Again, Automake, Autotools, so it's so complicated. The scripts are unreadable. I rest my case. I mean, what is more clear than that? Anyway, we register this in Git. And then finally, we are now going to write some Algol 68 code, even if it is very, very little. So let's write at least the main source file of our project, which is gramp.a68. All right, since we installed in the last video, we installed the Algol 68 mode, we have full syntax highlighting and bell and whistles in Emacs. So, what is an Algol 68 program? And this is our first incursion in the Algol 68 jargon and world. In Algol 68 jargon, and this is a programming language which is orthogonal, actually it's the most orthogonal programming language. The concept of orthogonality in this programming language design was invented by Adrian van Wingarden, who was the main author of Algol 68. When you have a programming language that has a lot of different concepts that combine orthogonally in an orthogonal way, it's very important to use very precise nomenclature, very precise terms, and because otherwise it's very easy to get lost. And since Algol 68 introduces a lot of concepts that are simply unique, a lot of those terms are like neo terms, right? Which is actually fun, but also requires to learn some new terms. Note something, this was not only true back in the 70s when Algol 68 was designed. You may think, okay, yeah, back then those terms were new, now they are not anymore new, and those concepts were new back then, now the concepts are not new anymore. So it's better to use the terms for those old concepts that are commonly used today. But as a fact, the concepts that many of the concepts that Algol 68 introduced back then, for which they felt the need to introduce very precise terminology for, are still new today. In the sense that when we use clause, the word clause, in Algol 68 to refer to a expression, it's not because we want to be special, or we want to be a smarty pants, or we want to use obtuse, intricate terminology to make people think we are super smart and they are idiots. No. It's because an Algol 68 clause, it's not like any other programming language expression. And to pretend it is to confuse everything. And is gonna confuse the hell of anyone trying to learn Algol 68. So instead of doing that, we just don't. We just use the Algol 68 terminology. And again, it's something that you will get used to it very fast, and it's useful to get used to it because you can discuss about details of a program in a very efficient way. Anyway, sorry for the excursion, but okay, so we will start now with using some of this terminology. So the first of the terminology is that some particular Algol system program, like ramp, is indeed called a particular program. So what is a particular program? A particular program is any enclosed clause. So enclosed clause, let's put it in a comment, sorry. Enclosed clause. I am sorry that my English is bad, but okay, enclosed clause. And so as a particular program, you can use any kind of enclosed clause, of which there are several in Algol 68. There are conditional clauses, like if blah blah. There are loop clauses, like for blah or while blah blah. And there are enclosed clauses. And an enclosed clause is a begin, whatever, end. So it is between begin and end. So in case of our program, for now, it's just gonna print a greetings and exit. So like welcome to ramp version 1.0, right? And exit. New line. Note that instead of \n, we are writing apostrophe n, and this is because in Algol 68, what is called, another terminology, string breaks, which are used for new lines, tabs, and the rest, they are introduced by apostrophes, not by backslashes. So welcome to ramp version 1.0, end. Now, little word on styling. You could write this. Okay, this will work perfectly well. Also, you could do this, right? Some people like to do this because it is similar to the style that you would expect to use in C or even in other Algol-like languages like Pascal or Ada. But I got used, by reading a lot of Algol 68 classic code, I got used to another style, which is you just indent like this, like you start like that. But of course, feel free to use whatever style you prefer. All right, so our GRAMP program for now, for the moment, is a particular program that consists in an enclosed clause. All right, here we will have like a header and license and distribution terms and everything. So GRAMP, the grammar manipulation program. All right, so as you can see, in Algol 68, at least using the modern stropping, some other day we will talk about the stropping regimes, which is supported by GCC, you write a comment by putting it in between curly brackets. Note that this style of comment is nestable, meaning that if you want to comment the whole thing, you will be able to do like just this. So you can nest one comment with another one, which is quite handy. Anyhow, so this is our program. It prints a greeting and then it exits. Let me add it here. So back to the build system. So we have makefile.am that declares the primary GRAMP, and now we got source code for the primary, for the program. So this is all we need here. All right, now let's go to the test suite and let's speed it a little bit because this is getting long. So here we also have a makefile.am file. Now, what is a test? That's the thing. What is a test? We will start by having like unit tests here. So the tests are programs that you run and either succeed or fail. And if it fails, you want a report and saying some test failed. That's it. That's a test. So what are test programs? So we are going to need a primary for the test. So let's declare, we have to declare a primary for the unit test. Now, the test you don't install in the system. You never do that. When you do make check after you build it, run the test suite. But when you do make install, you don't expect the test suite usually to be installed in the system. So those are not installed, but those are programs, right? So we are gonna call test ramp. We are gonna have one test driver for all the unit tests for the moment. So here we are declaring a primary like we did in the SRC. Now, we have to specify the sources. .a68. And then again, if we wanted to apply some particular flag to this, we will do like this. But actually we don't, at least for now. Yeah, well, okay, I don't know if to do this now. Okay, yeah, let's do it now. Yes. SRC, because obviously this unit test here, which is under test suite, it needs to access somehow the sources in the SRC because it has to test the code that we write in the program. So this is minus big I, that this is a compiler option for the include path, which is very much like in C. All right, so we have defined, so when you do make check, it's gonna build this test ramp program. Note that when you have a primary whose name contains something that is not a letter, a digit, or an underscore, some sort of like a special character like dash in this case, in automake expect it to be normalized to underscore character when you use it to refer to the primary in another variable like this. This is very easy, natural. Okay, but we are not done with this makefile.am. Why? Because you also have to specify to declare what tests are run, executed when you do make check. And you just specified here, this is a list. If we had another one, we could test foo, right? So there are you are doing two different things here. One is that you are specifying a primary here, which is this program test ramp, which is the source file, and using these compilation options. And this program is going to be built when you do make check. Built, but not executed. And then if additionally you want to execute the test when you do make check, which makes sense, then you add it to this test variable here. Okay, we add this. No, okay, I did this already. Okay, now we need a source file for this unit test. So test ram.a68, and then here we are going to use a particular program, and this particular program is going to do for the moment nothing, basically. For the moment nothing. So we are going to put here skip. So skip is a clause as well, so it is a skip clause, and basically a skip is a unit, so it is some sort of an expression that yields, so that results when it's executed in a value having the proper mode expected by the context. In Algol 68, a mode is a type. We call types modes, and so in this context, a skip basically is like a NOP, right? It's like a no operation. But between the begin and end, you need to put something, because this is not correct syntax, so we put the skip here. You can also write a skip in Algol like this. And yeah, okay. Something else that we want to put in the unit test, in the test program. This is a program. When you execute this, nothing happens, but it is a program. So from this test ramp, we want to test functions, procedures that we are going to define here in the main program. So, okay, never mind. Never mind. Okay, so this is the test. The test is like an empty program, basically. For the moment, it does nothing. Good. And basically, we are done. We are done. I mean, we have a top-level makefile.am, makefile.am in SRC, makefile.am in test suite. and this configure.ac. Okay, so let's make sure that everything is in Git. Okay, let's commit it. Okay, now once we have the sources, so this is what we will put in Git, more or less. There are some missing stuff. So the Autotools, they expect certain administrative files to be around, like an authors file, like a copying file, and so on. This is because in the GNU project, the Autotools were created mainly for writing GNU software, and in the GNU project we have a lot of standards and a lot of, which is what gives the GNU software this uniformity it has, and it makes it so easy to build it and so on. So if we do autoreconf here, which is the program that you have to run to get the make files and the configure script from the source files here, it's going to complain. And it's going to complain because there are certain files that are required that we don't have here in the tree, and some of them can be provided by the Autotools, like this missing script and so on. Some of them we have to write. So if we do autoreconf -I, which is install, some of those files is going to basically install them from you see, installing build-aux, install sh missing. So if we go to build-aux, this test driver missing can install.sh, it has been installed from automake or autoconf with the autoreconf script. Now, do we want to have those files in our Git repository? No, because the user, the developer user, when it checks from Git, should do autoreconf. The end user that will get the distributed source tarball will not have, we will see that, to have those to have Autotools installs. Okay, so which one are the files that are required but are not found? Authors, okay, we just oblige. Oops, I was gonna use my work email, I should not do that. Okay, we register the file, an authors file. What else? Install file, a news file, it requires, okay, we just oblige, you know, news for the grab. Again, this can be empty at this point, and I think that's all. So now if we do autoreconf, well, a changelog. There is a way to actually tell automake and autoconf to not be this strict, because we can say, okay, this is not GNU software, something that you put in the automake, in the configure.ac or the automake.am, but I don't recall what it is, so look it up. Anyway, let's use a changelog, why not? Okay, so we start with an empty changelog. That's it. So it got happy with it. So let's add those new files. Okay, they are already there. So git commit and all those additions, because we are running Autotools, they are generated files. They are already generating a lot of stuff that we want to git ignore. So what we do is that now it's time to expand our git ignore. We don't care about it. We don't care about it. We actually don't care about any .in file, but let's be cautious here. Let's just put makefile.in. This will cover all the makefile.in in the subdirectories. AC local, we don't care. Anything that goes in that directory, we don't care. The build-aux, we don't care. And the configure script itself, we don't care. Okay, full. All right. So now we are back to the reported working tree clean. Cool. Now, we actually run autoreconf, so now we have a configure script. So in principle, now we should be able to build our program. So we create a build subdirectory, and we call the configure script. Where are we going to install this program? default, which is user local. Okay, so what is the configure script doing? It's doing like some check-ins, some checks, which are like sort of a standard from autoconf. It looks for AWK, and which is relevant to our interests, it checks for a GA68 compiler, which is in our path because we installed it in the last video, right? And it checks whether it works, and it says yes. Under the scene, what the configure script is doing is that it is using the compiler it found to compile a small little Algol assisted program, and then it checks that it got compiled properly. And it checks for the compiled default output file name, it files out about that. So now the sources has been configured, now we have a make file, so we do make. All right. Now we are in business. Now, when we do make, it enters in the src subdirectory, and then it invokes, it uses the compiler in order to compile it. Then note that it uses like the default -g -02. This is the default A68 flags, similar to the default C flags to use. By default, it builds with the back info and optimized. But we can change this. Like for example, we can do make clean, and we can do make A68 flags and say, okay, I don't want the back info and I want to optimize even more in theory, right? -03. Did you see? It obeyed it. Okay. Now, GCC gives us a warning because I am a moron. So we should start here like doing fixes. What I'm doing? I don't know what I'm doing. Okay. So the problem is that we don't need a semicolon there. Okay, it's because I was showing you before, like, you can do this, and then I forgot to remove the semicolon. What is between begin and end in Algol 68 is a serial clause. And the serial clauses are units separated by semicolons, right, which are elaborated sequentially. Okay, so we get rid of this, and if now recompile, now we have no warnings. Cool. So basically, this compiled the program. Now the program is here, src grump, and if we execute it, we are getting the greeting message, and it does nothing else. Okay. Now, if we do a make check, then it's gonna do two things, as we saw. If we do a make check, it's gonna first build the test program, and then it's gonna execute it. And actually, I think it built it at make time. Did it make it? Yeah, it built it at make time. Okay, even better. Okay, so it builds it. I thought. Okay, never mind. This makes actually more sense. Okay, so it now just executed it, and it says pass because there is no way the program can fail, right? Okay. So the next thing that we can do after we do make a make check is to install it. So we do make install, but we can't because it is in user local, so we have to become superpower, and then we install it. Then at this point, we have our ramp in user local build, and we can execute it. Okay, now, okay, the last thing I want to see here is, all right, imagine that we are happy with our ramp program. It's not the case because we just started it, but imagine that we are just happy with it and we want to distribute it. Now, when you use Autotools, you don't want to distribute. I mean, the Git repository is for like developers, so that's the idea, right? Or power users, what do you want to call it? Because when you do a Git clone, observe that in the Git repo we have the makefile.am. Obviously, we don't have the file generated by automake, which is makefile.in. We don't have the final make files, which are only in the build directory, but also we don't have a configure script. So in order to generate the configure script, you need autoconf. In order to generate the makefile.in from the makefile.am, you need automake and autoreconf and this and that. Now that is perfectly okay for developers, but you should not impose to the users to have the right version of Automake or AutoConf installed in their systems to build your program from sources. In the GNU project and in free software in general, it's very important for users to be able to build the programs from sources in an easy way. So basically, to the user, instead of pointing the user to the development Git repository, what you do is that you give the user a release tarball. How do you make a release tarball? Make dist. So with make dist, what it is that it created this GRAMP 1.0 target set, which is this is a release tarball. Now, if you take a look at the content of a release tarball, you will see that it contains the source files, the makefile.am and the configure.ac and so on, which is stuff which is in the Git repository. But additionally, it also contains whatever is necessary and generated by the Autotools, like the makefile.in and the configure script, so the user can untar this tarball. We can do that. Imagine we get this tarball from somewhere, then and then we untar, right? And then observe how Automake added the version to the name of the tarball. Then here we could do like configure. We did not have to do auto-reconf because now we are a user. We are a user building a source tarball. So we just do make and make install, right? And for that, you don't need the Autotools. You don't need Automake, AutoConf, or anything like that. In principle, all you need is a shell, portable shell, AWK, make, and well, and obviously GCC and the other development tools. But this is all, and this is the magic of the Autotools. All right, so we are basically done here for today. What we achieved today is that now we have our project in a Git repository in local, in a working copy, and we have a sources directory, we have a test suite. So from now on, we can start focusing in actually writing our program, adding unit tests as we progress, and this is all for today. So thank you for watching and happy hacking.